Displacement. There's a whole bunch of stuff we need to know about displacement. Please just tell me one thing. Kate? There are a whole bunch of things we can talk about displacement. Just give me one. I can almost hear there's a lot of shuffling. Distance between two things. 2 points. 2 specific points. What are the 2 specific points? Ezra. Right. Yes, it is the straight line distance between 2 specific points. Austin.
It's the difference between the final and the initial.
This 2 points would be the final and the initial position. So displacement is the straight line distance between the initial and final points. True. More stuff about displacement. Tina.
It has direction.
Notice that displacement has direction. More stuff about displacement. Arjun? There's a whole bunch. We just need more. For example, we don't have a symbol for it. Just as an example. We don't have an equation. We don't have dimensions for it. All sorts of stuff. Right. I'm hoping to be able to write them down because you, as a student, bless you, will be able to tell me these things. Would you agree, as a teacher, sometimes I can assess how well someone read from questions I ask in class? Would you agree, students?
Yeah.
That this is something I can do? It's so much fun sometimes. Arjun, you are telling me something, are you not? You are! Sadly, it is not good stuff, is it? No! Please try to avoid telling me these things in the future. Ben!
It's measured by final minus initial.
Final minus initial. Okay, let's write that down. Final minus initial. Actually, I can't quite write it down yet because I don't have enough symbols. I agree, final minus initial. Your shot.
Delta x.
Delta x, okay. Let's start with the symbol for displacement. Delta x. True. Okay. What does delta mean? Spencer. Go ahead. That's fine. You had something else. True. It does. It means it's delta. It's the letter D in Greek. I agree with that. Rachel?
The change in something?
Okay. So delta means the change in. And I didn't write it very clearly, but it's a triangle. Delta, change in. Okay. What does x represent? Your shot.
Distance.
It does not represent distance. It's not quite distance. Ben Slanbrook?
Is it for like the horizontal axis?
I agree, it does have to do with the horizontal axis, more specifically, however, Megan?
Position.
Position. Position along the horizontal axis. So delta x, which is the symbol for displacement, literally means the change in position of an object, right? So let's write that down. Displacement can also be thought of as change in position of an object. Okay. Delta x, change in position. Okay, Ben, you said, what did you say?
It's measured by taking the final point minus the initial point.
The final, we'll call it position rather than point, the final position minus the initial position. Notice x stands for position, so this is position final minus position initial. As Lindsay pointed out, this would be along the x-axis. You could also have it along the y-axis or the z-axis or whatever axis you wanted to. We'll just start with the generic x-axis. So far we have displacement. It's a straight line distance between the initial, bless you, and final points. It has direction, and it is, the symbol for it is delta x, which literally means the change in position of an object, and position final minus position initial. Okay. What else?
The equation Or is delta,
That's okay, we got that up there. We kind of built that all in there. Delta x equals position final minus position initial. Frank?
it can be positive.
Notice it can be positive or negative. Common dimensions for displacement here. Taylor. Common dimensions for displacement. Meters. Give me another dimension for the displacement, Alejandro.
Don't know.
Oh, come on.
Feet.
Feet! That was rough. We'll come back to Arjun. Kilometers, sure! How about furlongs? It doesn't really matter, okay? Any sort of linear dimension, clearly the most common would be meters, probably then kilometers, things like that. Let me see if I have anything else. Oh, just so you know, this right here would be called the magnitude. The magnitude, which would be the amount of the displacement. So displacement has both magnitude and amount in meters, and it has direction. One important thing to understand here is that displacement is not the same thing as distance, bless you, travel. Displacement does not equal distance. Now, let's put some coordinate axes on here. You could have positive y, positive x, negative y, negative x. You can have up, down, to the right, or to the left. Notice that up corresponds with positive for positive y. To the right is also positive, corresponds to positive x. Down is generally negative, and to the left is generally negative, corresponding with negative x and negative y. You can also have cardinal directions, as in north, south, east, and west as well. So we can describe the direction in all sorts of different ways. To make sure we understand direction, bless you, please take a moment and point, class, north. This is kind of fun, just so you know, north is straight in front of you right now. It makes it easier as far as, we'll get there, as far as orientation is concerned. So again, point north, south, west, east, up, north, up, north. Class, are up and north the same thing? No, very commonly they are confused. North. Okay? I understand for some reason we like follow the map, it's like, woo, look, it's up. No, okay. North is forward for you in here, and up is up. Okay. Let's do some simple examples. Let's say I start here. And I end here. Let's say that there's approximately 4 meters between those 2 points. Jimmy, what was my displacement? 4 meters east would be a description of my displacement. Give me another description of my displacement. Eric.
4 meters right.
4 meters to the right. So far we have 4 meters east, 4 meters to the right. We could also say 4 meters in the positive x direction. Right? So those would all be examples of my displacement. All right, let's do another one. Let's say I start here. And I end here. Brad, what was my displacement?
Nothing.
More specifically?
0.
0. 0 what? Correct. Can you have distance on 0? Like, can you say 0 meters, 0 feet? Does it matter?
No.
No. Can you have a direction on 0? No. So my displacement is 0. What was my distance traveled, Frederick?
0.
No, my distance traveled was not 0. Spencer?
8.
8 meters, right? So my distance traveled was 8 meters. Notice the difference between the two. So displacement and distance traveled are two very different things. How about this one? What was my displacement? Karen. Oh, not quite. Lindsay?
4 meters.
4 meters east, right? My displacement was 4 meters east. Hold up. Did I do the same thing? No. So what was different? Alejandro?
More distance traveled.
The distance traveled, okay? So the distance traveled was very different. What do we know about my distance traveled? Austin? We don't know its value. All we know it's greater than 4 meters. Great. So notice, distance traveled and displacement are two very different things. Yes?
Distance traveled must be less than the displacement.
It's a good question. Can distance traveled ever be less than displacement? Distance traveled ever less than displacement? Claire?
No,
Why not?
because the distance traveled has to be at least as much as the displacement. Because you have to travel however much you're displaced.
The displacement would be the straight line distance, right? So that would be the minimum distance between those 2 points. The absence of wormholes and things like that. So in this class, yes. And in all forms of reality that we know, yes. Okay.